Now, in these pictures, there's actually some difficulty. I wouldn't say necessarily bad news, but there's some difficulty. Now, it's not for the customer. We've established higher quality, more affordability for more people. So where's the difficulty? Well, imagine you're responsible for managing the design of the 1964 Ford Mustang. What do you have to do? Well, you hire a bunch of mechanical engineers, stick them in a room, give them some graph paper, engineering tables and charts, slide rules, coffee and donuts, of course, to fuel them. Tell them, design me a great car. And they do. They sit down and say, well, you know, performance is a factor. That tells us how many cylinders. Once we know how many cylinders and we know how much power we're generating, it tells us about the radiator. We know how much power we're generating, it tells us about the gearbox and how we have to manage the torque out to the rest of the car, which tells us how we have to design the drive shaft. Once we got that, we know about the rear axles and the tires. And once we know the size of the powertrain, it tells us about the size of the body. It's a very straightforward design process. Not only is it straightforward, but it's all done by mechanical engineers who largely understand steel, because everything in that car is steel. Now, fast forward. You're responsible for managing the design of the 2010 Ford Mustang. You say, well, probably need those mechanical engineers. Turns out that's not enough. Because the ones you hired who understand steel, they need to be complemented by some who understand aluminum, because it's an aluminum engine. Then they start designing the engine, and they're immediately going to hit a roadblock. Because they've got the physical shape of the engine, and they understand something about the shape of the cylinders and the combustion going on inside. But the valves letting the fuel and air into the engine, they're electronically controlled. They need some more engineering buddies from a different department. Then the electronic engineers are inside, but they need some help from the computer software people to write the code which is going to control the electronics. It just gets worse, because then you're going to have to get fuel into this. No more carburetor, you got the electronically controlled fuel injector. They said, oh, I got the electronic people and the software people. Yeah, but you don't have the people who are masters of ceramics and plasters and rubbers and polymers and all sorts of these other materials which have to work in this very hostile environment. And it just keeps getting worse. If you're managing the design of the 2010 Ford Mustang, you got to keep adding more and more specialty into the room. You have to have the people who understand telemetry, people who understand sensors, people who understand signal processing, people who understand control theory. It just goes off the chart. You need a very, very big room and, of course, a lot of coffee and donuts for all those specialties in the room. But it gets worse than that. See, the thing is, remember 1964, what do you need? Performance. It tells you about the engine, which tells you in turn about the radiator, and the gearbox, which tells you about the drive shaft and then the body. But you make what seems to be a simple choice in a modern car. Let's say add glass to the front windshield. Well, you add glass to the front windshield in a car which you're going to cruise around with the top up to listen to the beautiful sound system. The car's going to get hotter in the summer. It gets hotter in the summer, you need more cooling. But look inside that engine compartment. Where are you going to put a bigger compressor? You got to move this thing for that thing and this thing. It's like playing with the Rubik's Cube, but with big, heavy, expensive stuff. And even if you don't have to move stuff around, or you've successfully moved stuff around, then you have to start moving power around, because you got to power up the compressor to power up the air conditioning. And as you start saying, well, where am I going to draw power from? People are going to start protesting. Whoa, hold on. I'm also drawing power from the engine for the braking system. I'm also drawing power from the engine for the skid avoidance system. I'm drawing power from the engine for the GPS or for the entertainment. A simple little thought like, let's add a little bit of glass. All of a sudden, you're worrying about how the radio interacts with the brakes. Well, here's the problem. So when you have a system which is really tightly coupled with all these different components, and remember, behind each of these components is a huge number of different specialties and functions and disciplines, and they're connected not in a simple linear, one leads to another, leads to another. It's A goes to B, B goes to C. So far so good, but C goes to M, and M goes to Z, and Z comes back to F, and F goes off to 3. Where'd 3 come in? And 3 goes to 12, which goes to the Greek letter rho, which comes back to sigma, which goes to Q again. You get everything connected in all sorts of very convoluted ways. It's really, really hard, dare I say impossible to figure out what actually has to be in the system. So the basic structure, you're not likely to get right on the first try. And not only are you unlikely to get the structure right on the first try, good luck figuring out how this system is going to behave when actually used. So the structure, even if you get the structure, you're never going to get the dynamics right on the first try. And this is exactly where innovation comes in as a necessity, not a choice. Because if you're responsible for designing, if you're responsible for operating something which is inherently complex, you have to, absolutely, positively, have to get it wrong on the first try. But wrong is not okay. Wrong is not all right. Wrong is not adequate. You want to be perfect. People want perfection. But if you can't get it perfect on the first try, you need a second try. And if you don't get it right on the second try, you need a third try. You need to get better and better and better. What you need to have is the capacity for nonstop, broad-based, high-speed improvement, innovation, and invention if you have any hope at all, of taking your complex system, be it a car or the factory in which it's made, and advancing with great speed forward in a relentless pursuit of perfection.